about the question that's been bothering everybody. So I'm going to put that down here now. This question. Okay? So we have to evaluate the following limit. Because we have a limit which represents a definite integral, we're going to first interpret this limit as a definite integral, and then we're going to answer our solution by just solving that integral. Okay? That's our steps. So let's show you how we're going to do that. I'm going to copy this over. So the question is taking the limit of n goes to infinity of 6 times, I guess that's going to be, let me just open it up here so I can kind of see what's going on here too, instead of going back and forth. So that'll be 6 and then k minus 1 whole squared over n cubed. And then you have a square rooted here with 1 plus 2 times k minus 1 whole cubed divided by n cubed, right? So what we have to pay attention to is, remember this. The limit of n goes to infinity of, in this case they're choosing k, so we can choose k no matter whatever happens. One to n of f of x I, or basically xk in this case, times delta x is going to be equals to the integral of a to b of f of x dx. Okay, so point number one that you need to realize is whatever's inside here is basically a function's value at x of k times delta x. We just need to decipher what the value of a, b, and that function is. Okay, that's all we have to decipher. So let's do that. Before we begin, okay, because for this particular example, it will be beneficial. I'll tell you exactly why it will be beneficial later. But we're gonna change this index. Okay, so I'm gonna be like, let k, whatever you have, I'm gonna call this new thing. I'm gonna call I be equals to k minus 1. Okay, I'm gonna introduce this new term. The reason why I do that, because then I would substitute this whole portion of k minus 1 and this whole portion of k minus 1 as I. And I'll tell you why. Okay, so let's do that. If you change that position to I, you have to adjust the bounds on k in terms of I now. Okay, so now because k start at 1, then I start will be at k start minus 1. Right, because that's the expression, right? So that will be equals to 0. And because k end at n, then I end will be equals to k n minus 1, which happens to be n minus 1. Okay, that's how you adjust the bounds, because you're changing the variable of index, or you're changing everything, so you have to make sure the summation is also addressed in that case, right? Limit of n still goes to infinity, right? So we'll still have the same expression there. Okay, so let's see. The new summation with the shifted index will look like this. And so we'll have I starting from 0 all the way to n minus 1, 6 I cube, no, I squared by n cube 1 plus 2 I cube by n cube. Okay, so now first of all, it looks much easier on your eyes. It was giving me a lot of trouble when I was looking at it without the substitution, right? But does this changing of index make sense to everybody? I did not do something crazy. It's just a way of interpreting things, right? And you'll see it'll make your algebra way easy. In just a second, okay? So right now, still, this thing still holds. This is f of xi now times delta x, right? So now we gotta remember some formulas. We gotta remember something, okay? There's no good way. Yes, so if you substitute in a summation, you would have to change the bounds as well, just like how you would do in an integral, right? If you do a u substitution inside an integral, you would still have to change the bounds to adjust the u values, right? If you don't plan to plug in the x value back. So that's why it's important to keep in mind that bounds also change. Okay? So that's why we have this. And now we have to remember that delta x has a form that looks like b minus a divided by n. Okay? So I'm like, I have to try to see, can I have a form of some number divided by n, which I can see that there? Not yet, but I'll show you how you can see it, okay? I'm gonna color code them. I'm gonna do this. Does everybody see how I rearrange things in the summation? Right, there was an n cubed below I squared, so I took out one of the n, put it into 6. So now I have a clear term with a number up top and n on the bottom, which resembles the form that my delta x should be. So now I can easily conclude that this portion is delta x, and the remaining portion right here that you see is f of x of I. This is very important because this is going to take some time. Even though if you cannot see this in the very beginning doing yourself, you know, like if you were to do the same problem, you would not be able to see this thing. But right now, when I put it like this, are you able to see and distinguish between which portion of this summation is the delta x portion and which portion is the f of x of I portion, right? Can everybody see that? Okay, which is good. So now I have a couple things to watch out for, right? I have a couple things to watch out for. Now I know the delta x is this, and I also know the x of I, which is supposed to be a plus I delta x, is literally turning out to be something else. So the reason why it's the delta x, because I want to make sure I resemble this form. Okay, I want to resemble this form there, where you have some constant divided by n, because that's how the form of a delta x is going to look like, right? The only term that has some constant divided by the n value looks like this. And I'm going to show you, because you probably seen that this is not delta x, and I'll show you. I'm going to put you in that contradiction, and then you should be able to reason yourself like why delta x is not exactly this, but something else. Okay, I'll show you that in a second, okay? So if you have a plus I delta x, we have seen that this is going to be just I over n. Right? We know the x of I, you know, that we see is just going to be I over n. So if x of I is going to be I over n, that means automatically that a must be equals to 0. That's one thing that we draw out of this, that a must be equals to 0. The other thing that I draw out, because there's something that's not working here. The reason why you will see that's not working is because if you chose your delta x to be 6 over n, okay, so once you see that deposition, that this, if you choose it to be 6 over n, the formula will not work out. So So let's try to see what happens. If you're going to choose 6 over n, then my 0 plus I delta x will look like 6i over n, which I don't have. Right? I don't have 6i over n. I have just I over n. So I must readjust my formula a little bit. Okay? I must readjust it. So what I'll do is I'll make it into 1 over n, and I'll have the 6 hanging out by itself. Okay? So that's another version of looking at this delta x again. So now if I choose my delta x to be 1 over n, you'll see everything works out. If you choose delta x to be 1 over n, then a plus I delta x, if you chose a equals to 0, would just be equals to 0 plus I times 1 over n, which is I over n, and that's exactly what we see, right? So it's like a puzzle, you know? Both the pieces should fall into place together. So that's what we see in general here. So if I was to kind of like reinstate this thing into a function here, you know that b minus a must be equals to 1 because of the form. You know a must be equals to 0 because you don't see any constant accompanying the I term. You know, there's no constant being added up with the I term, so a is going to be 0. Now you know b minus a is equals to 1, and a is 0. That implies b must be equals to 1, right? So I found my b value, found my a value, and I kind of have the way the function looks like. Okay, so this integral is going to be from 0 to 1, because that's 0 to 1, of 6 times, this is going to be squared, so this is going to be x squared, and square root of 1 plus 2x cubed dx. Okay? If you pick up our a and b value, that's out of the way. You just got to see whatever's going to be the framework of the function is going to be what the f of x is going to be. Okay? That's how you kind of lay it out. This was the first example that you saw. Okay? So now evaluating this limit is evaluating this integral, which I'm pretty sure you guys can do without any help. Okay? This will be a u substitution integral, so there's no trouble there. I do want to take this, so you got to bear with me. I know it's a little bit hazy, but I'm going to show you one more example. And then once we see examples, it will start to make a little bit more sense. Okay, let's go over another example where they've given us a question and we want to convert it back into the area.